Let's welcome our first presentation by Zhao Jiangling. Jiangling from Automotive Research and Development Center, Guangzhou Automotive Group. Dr. Zhao is the Chief Engineer of Hybrid System Integration Department. His research interests include hybrid electromechanical coupling system design and hybrid control strategy. The title of his speech is Hybrid Electromechanical Coupling System Optimization. Okay, let's welcome Jiangling, please.
Hello everyone, I'm Zhao Jiangling from JC. Today's presentation is a hybrid electrical mechanical system optimization. At this time, each country develops hybrid vehicle according to different conditions and their own situation. Different technical routes have been adopted. American mainly adopts the power split system, European mainly adopts the P2 system, and Japan mainly adopts the power split system and the serial parallel system. For China, the serial parallel system is mainly adopted. In order to optimize globally, we define three basic configurations. The first basic configuration is the serial parallel scheme. This scheme it includes the one motor EV, double motor EV, and the engine have 1 to 3 speeds. The EM2 have 1 to 2 speeds, and includes the extended range model. The second basic configuration is the power split scheme. This scheme include single motor EV, double motor EV, power split model, 1 to 2 speeds of EM2, and 1 to 3 speeds of engine. The third basic configuration is the drive model include single motor EV, and the engine have 4 to 5 speeds. Firstly, we identified vehicle parameters and performance targets. Vehicle parameters include vehicle, battery, engine performance. Performance targets of the vehicle include fuel consumption, costs, acceleration time, and so on. Development targets focus on fuel consumption, costs, and acceleration time. As shown in table, for the serial parallel scheme, the engine can have 1 to 3 speeds, and the EM2 can have 1 to 2 speeds. There are 6 combinations in total, and each combination is optimized. In this way, the following points are analyzed. In the serial parallel scheme, how many gears are better for the engine and the EM2, and determines the ratio of the scheme and the motor parameters. We can see the simulation results of the 3 different engine speeds. The simulation results of the engine 2 speeds and the 3 speeds are similar and better than the 1 speed. Highest fuel efficiency and drive performance is achieved with 2 speeds. the EM2 speed number has little impact on the economy performance. Low consideration of transmission costs because of missing transmission structure. Lowest EM and PE costs achieved with two-speed and 3-speed configurations. 2 and especially 3-speed configuration might cost higher costs than 1-speed. Low consideration of transmission costs, lowest EM and PE costs achieved with 1 configuration. 2 configuration might cost higher than 1-speed. This is the top 10 configuration of the series parallel scheme system. From this table, we can find the top 10 are engine 2 speeds, EM 2 speeds, and also find each ratio, power, torque, costs of the engine and the motor. On this page, we can see the simulation results of the acceleration performance and the fuel consumption. As shown in the table, for the power split scheme, the engine can have 1 to 3 speeds, and the EM2 can also have 1 to 2 speeds. There are 6 combinations in total, and each combination is optimized. In this way, the following points are analyzed. In the power split scheme, how many speeds are better for the engine and the EM2? Determine the ratio of the scheme and the motor parameters. Regarding WTC, 3 speeds of the engine offer a small potential for the fuel consumption. Regarding NEDC, 2 speeds are enough to achieve the best compromise between the fuel consumption and acceleration time. Through the sensitivity analysis, we believe that for the power split scheme, the optional solution is 3 speeds for the engine and 1 speed for the EM2. This is the top 10 configuration of the power split system. From this table, we can find the top 10 are engine 3 speed and motor 1 speed, and also find each ratio, power, torque, costs of the engine and the motor. On this page, we can see the simulation results of the acceleration performance and the fuel consumption. On this page, we can see the simulation. This is the optional of a single motor hybrid scheme is mainly analyzed for the 4-speed and the 5-speed scheme, as shown in the table. 5 speeds offer the best compromise regarding the fuel consumption in WTC and the acceleration time. 5 speeds offer the best compromise regarding the fuel consumption in NEDC and the acceleration time. This is the top 10 of the configuration of the P2X. From the table, we can find the top 10 are engine 5 speeds, and also find each ratio, power, torque, costs of the engine and the motor. On this page, we can find the simulation results of the acceleration performance and the fuel consumption. In the early stage of the technical loads selection, we consider a fuel evaluation factors, including only acceleration performance, fuel consumption, and costs. In the final scheme selection, the control difficulty, the space, the MH, performance, and other factors are integrated to make a comprehensive evaluation, and the optional scheme is selected. Therefore, we choose the series parallel hybrid system scheme. After determining the series parallel system through the simulation calculation, the series parallel system with 2 speeds for the engine and 1 speed for the EM2 is finally determined. This system can realize the function of the dynamic coupling of the engine, generator, and the drive motor, and have different working model at the same time, as shown in table, including single motor EV, double motor EV, and the extended range model, hybrid drive model, and so on. This is the power flow of the hybrid system. In this paper, 3 basic configurations are established. Then the optimal solution of each basic configuration is obtained by optimizing the 3 basic configurations. Finally, the 3 different technical routes are compared comprehensively. The series parallel systems are selected, and the configuration design is carried out. This paper systematically describes the whole process of the hybrid electrical mechanical coupling system design, which can provide a reference for the design of electrical mechanical coupling system in the industry. That's all. Thank you.
Oh. Okay, thanks to Dr. Zhao for sharing their work on optimization on the configuration for HEV. Okay.